A very good afternoon, everyone. Welcome to the Singapore Geospatial Week Plus 2020. Hope everyone had a good lunch break. We have with us today two speakers from the Singapore Land Authority who will be presenting on two topics. First, we have Victor Khoo, Director, Survey and Geomatics Division, who will be speaking about the Advancing Singapore Digital Twin. And we also have Chun Hong, Principal Executive Systems and Support, Land Asset Management Division, who will be speaking about MAGE, Managing Contractors Through Geospatial Technologies. Without further ado, I would like to invite Victor to begin his presentation. Victor, please.
Good afternoon, all from Singapore, from this region. Good morning, those who tune from Europe. Good evening for Australians and New Zealanders. So I'm Victor. I lead a team in Singapore Land Authority. The division that I'm working in is known as a Survey and Geomatics Division. Before I joined SLA, I have about 8 years of experience in research, particularly in the area of remote sensing and GNSS. And for the past 18 years, I've been working in SLA in the area of geospatial and geomatics. So the team that I'm working in SLA, Survey and Geomatics team, we are a technical team with expertise in geodesy, surveying, geospatial data management, and geomatics. And the area that we are focusing in is national positioning infrastructure. We provide that infrastructure to support all kinds of differential GNSS positioning. Another major area that we work in is the creation and maintenance of national 3D maps. That forms the backbone of what I'm going to talk about today, the Singapore Digital Twin. So this is a journey, definitely, which we have started 8 years ago in 2012. The journey continue, and today I'm sharing with you our journey of developing, sustaining the Singapore Digital Twin. So I will start off with giving you some background about digital twin. What do I mean by Singapore Digital Twin? The motivation of working on it. What are the geodata framework that we are looking at? The program that we have to sustain this framework, the architecture, and I'll end up with applications. So digital twin is not new term or new technology. It has been around for a long while. In healthcare, in automotive, in manufacturing, we heard about this term. So it is a digital representation of people, processes, system, places, devices, and things. It is not just about the object, but it's much more than that. So this is beyond just the GIS that we used to know. And in this case, city as a system is quite a new concept, new idea, and we are going to talk about digital twin for the city today. So digital twin for city, some may call it geo-digital twin. The concept has been around for not long. In Europe and in Australia, the cities and the governments have been looking into this area and have started to develop models towards sustaining a digital twin for the cities. So for geo-digital twin, particularly, what is this, right? So there are 5 points here. It represents asset in the physical world with digital model, looks and feel like real environment. So it's not just a model, but it has the visualization. You must be able to do simulation and all kind of analytics in the model itself in a different degree of fidelity. So the level of details is important. It cannot be just one level of detail. It's not just a model, it must include relation, interaction. What it means is that the object in the city model or in the digital twin should be able to interact with each other. And last but not least, there's a time element, there's a temporal element in the digital twin that makes it a digital twin. I need to go quite fast because I have quite a big deck of slides. So let me proceed. The motivation, why do we start this initiative of developing the Singapore digital twin? We know that the cities of tomorrow will be powered by digital twin. It's an important few element that will power the city of tomorrow that is sustainable, that's resilient, and that's smart. In our case, we have these four development principles when we want to work on this digital twin. We know that it has to be smart. The data, the information in the digital twin have to be accurate, reliable, consistent, and interoperable. These are all four major development principles. And with this principle, we work on each one of them. In terms of, we know that the model needs to be 3D semantic based. It has to be based on a 3D mapping technology, accurate way of capturing the data and creation of the models. We know that this should be the single source of truth that provides the core geodata for other scientific studies and other new products to be developed on top. So whatever that produced in the digital twin has to be fundamental, interoperable. We know that we want it to be captured once and used by, and because the cost of doing it is not cheap, and we should understand the technicality behind it. What would be the resolution? What kind of data do we capture and do it once to be able to serve as many usage as possible? So we also said that the core function, there are three of them. It must be able to meet analytics requirement. The different types of analytics, modeling, in simulation, optimization. So the data, the geodata, the data sets that's been created must be able to meet this requirement. The other important area is that it must be able to meet the requirement for automation to support sensors and IoTs, autonomous mobility, robots, and many other digital initiatives. Last but not least, visualization, because a digital model should look like the real world, right? So it has to be photorealistic. From a visualization perspective, it's not just covering what is above ground, it should look at underground as well as surface, and 3D as well as 4D, which is the time aspect. So all these can be achieved through visualization. So what is this digital twin that I'm talking about? It is not a system. It is not an IT software or IT portal. It should not be based on one proprietary technology. The core of the digital twin is the data, basically. It's a 3D data. So here, we know that at the core, there are three components here. One is a 3D semantic-based city model. I think a lot of you have heard about CityGML. We believe that this is the core data sets that would be the main character in the digital twin. The other important aspect of the digital twin would be the ability or the framework that can continuously update and refresh the data in the digital twin. So you need a program to be in place. In our case in Singapore, we have the 3D National Mapping Program that is based on two technology, the aerial imagery and aerial laser scanning technology, together with the mobile mapping techniques that capture the data and provide inputs to the digital twin continuously. And last but not least, very important, when you have all this data, you need to have a 3D data management framework, which need to be based on a database management system, as well as moving into the future, we need to look at knowledge representation and management. I'll elaborate a little bit about that later on. The whole idea here is that with all the geodata that we get, data integration is important, data interoperability is important, to be able to put together all this into something what we call Singapore digital twin. So this is not the same as in the old days when you have GIS data, layering, trying to put them all together. What we are looking at is object-based models, and there is a lot of work now to look into linked data ontologies and how do we move forward with more intelligent and smart data sets. So I'm going to go a little bit deeper into the three components or the three core components that we are talking about. First is the semantic-based vector model. In this case, CityGML. I think many cities in the world now, especially in Europe, have already turned towards CityGML as the standards that form the 3D city models for their digital twin, right? So CityGML is not new. It is an open standard under the OGC, and it is described in 5 levels of details. So in this case, you see LD0 until LD4. In our case in Singapore, we are focusing on LD0 to LD2. We don't believe that we are able to produce LD3 at the national level, and also the application LD3 actually is not too many. So at this point of time, the digital twin that we are talking about in Singapore would have a 3 levels of details, which is LD0 to LD2. The CityGML model is a semantic-based model. It has the 3D geometry, the topology, the semantics, and the appeal for the core model to be used. There are also different ways of looking at the level of details. So in our case, based on the TU Delft work, in Singapore's context, we are actually looking at LOD 0, LD1 in terms of slightly more detail, LD 0.2, LD 1.2, and LD 2.3. This would form the basis for the data that we have, the 3D city models that we have in the 7 teams under CityGML. So this is the part about the semantic-based data model. When it comes to data capturing and data updating, in Singapore's context, we have the National 3D Mapping Program. It has been a long-running program since 2014 with airborne aerial mapping, ground-based on the technique and technology evolve over time, and we actually update and upgrade the way we capture our data. In terms of the area mapping, we are using state-of-the-art technology that can do rapid mapping to cover whole Singapore. So from the data perspective, we adopt oblique imagery, including near infrared. So this is very rich data sets that form the basis to create all the 3D models, all the 3D and 2D data sets that is being used in the digital twin, or the point clouds from airborne is a very important data set because that gives you very good, in this case, if you look at the data that we have captured, the point clouds, through data classification, we can actually separate the data, and there's a lot of usage to these 3D data sets. The products, the very fundamental products that have been created from the airborne imagery and airborne laser scanning are the digital terrain model and digital surface model. And you notice that these are all huge data set, and it is not just from one campaign. It is from many campaigns, and we would have a lot of history, a lot of rich data sets that we can work on. Through photo, this is also a must for any digital twin, photo-based map, that is high resolution and can be used for many purposes, including using it to texture the 3D models. Of course, the city GML building models is another basic models that comes from the aerial mapping, and this work have to continue over time to model for the new buildings and to remove the old buildings from the whole data sets. Last but not least, another important data set is this data set known as the 3D reality mesh model. It may not be a smart model or smart city model, but there is a big advantage of this kind of model. It is complete. You can model every single object that you see on the ground, including all the trees, and this is useful for certain applications. So in our digital twin, it includes all these components. The airborne data set gives us a very rich set of data. On the ground, we also carry out mobile laser scanning. The point clouds and the 360 imagery also give us a huge amount of information and geodata to work with. So we talk about the data and the data capturing. The third component is the data management. This is an important part in the team. We need to continue to work on this. Basically, there are two main components. We need to manage all these data in the database as well as to look into geodata framework. In this digital twin, it consists of 20 types of data sets. You can see here 14 core data sets. A lot of them you have seen that I mentioned comes from the aerial imagery and the aerial laser scanning, as well as the ground-based mobile laser scanning. Besides that, there are also another 6 important data sets that all together form the Singapore digital twin. That is very useful for many agencies and many geospatial applications. This includes BIM models, 3D address, positioning infrastructure, underground assets, and so on and so forth. So you can look at these slides. From the life cycle, the data life cycle perspective, what we believe is that we need to understand that there is this capturing portion, there's this modeling portion. All these are technical. It has to be carried out following certain specification, following certain right techniques, in order to achieve the data set, the geodata set that we want in the digital twin. And we need to have a very good data management regime that includes data governance. And last but not least, the digital twin itself is a huge data set, but we need to have capability to use it, to be able to deliver it to the different user. Different user or the different agencies may require different way of using it, and we need to have a capability to be able to work with all the data sets that I'm talking about, understand them, and be able to deliver it. I'm going to go a bit faster. So what we see as the architecture of the digital twin, there are 5 levels here. It is not just the platform or just the system, but the main important thing is where must be the source of the data coming from. You have the national mapping program, you have the precision infrastructure, you have the regulatory submission. So a lot of data, for example, the cadastral data comes from the regulatory submission and other GIS data source. But all these we must know where is the source, what is the quality, how do we work with each one of them. And of course, the data itself, this is what we call core data sets. And on top of that, there's information, because from core data sets, you can generate very basic products and core information that is useful for many applications. But in order to show these data sets, to use these data sets, you have platforms. So there can be many platforms that would be able to use and digest and apply all this data that has been created. And last but not least, on top, what are the applications? In this case, we want to divide it into 6 major areas in terms of the application. I'll go into the detail of these 6 areas later. So the question is that, where is the scope, the boundary of digital twin? Because it can involve many other different types of data. What we see here in Singapore's context, digital twin itself, if you look at the data framework, the geodata framework, the 20 types of data, that would be the core. And it has interface, it should have interface to the different systems. The different systems also generate different types of data and applications. So here we are looking at system of insights, system of engagements, products and devices, other twins, system of workflow, system of records. Digital twin is in between. And again, from the IT perspective, we need to be able to understand the interface. How does it work? How the data pass over? How the other data set pass into the digital twin to enrich the digital twin. So this is the model for the interfaces with many other systems. And again, the other portion of this digital twin include the capability of location. That's what I want to say here. For any application, if you only know your map or your location or your 3D map, your digital twin, it is just half of the solution. In a lot of applications, you need to know where you are at any point of time, and the capability to locate is important. And in this case, we are talking about precise location in 3D, in real time, anywhere in your digital twin. Yeah. So in Singapore's context, we operate the precise GNSS infrastructure, and that provide this kind of capability that can work with the digital twin, so that smart solution can be implemented. The last part of what I want to talk about is the 6th area of applications. Security and safety, environmental risk, resource management, urban planning, infrastructure development, and city. This is how we look at the digital twins application area of application. There are many different types of application. What I want to share with you today is just a few of that I think is quite interesting and which I want to share with you. First one is about climate change, fighting climate change. In Singapore, we know that this is a big issue. From the digital twin data sets, we are able to create very precise, very good seawater rise map. And this is a map that the policymaker is used to protect our coast, right? On top of that, from all these data sets that have been captured in the digital twin, we are able to create coastal protection map. We know our coastal in detail, not just in 2D, but in 3D, are able to produce the map and are able to have strategies using the map and strategies to protect all these places. So these are real projects that have been in progress, and SLA, my team, is working closely with the different agencies. The other very key project is about the solar potential map, creation of the solar potential map in Singapore. So this is a completed project. We have been using our data sets to create solar potential map in 3-dimensional, both for the rooftop and for the facade, that covers all the buildings in Singapore. And this is a good set of information for solar energy roadmap in Singapore. I'll go a bit faster. Besides that, the data sets, the point clouds, the imagery, all these are very good basic information for us to map other objects. In this case, it's a tree. We work closely with NParks and going into a development where AI can be used to extract tree information from all the 3D data that we have captured through the digital twin program. Another interesting project is our work together with the Health Science Authority. The data set, vast data sets, are used to model the accident scene on ground. This has saved a lot of time of the agencies. The data can be reused, recycled for many purposes. One other important area, big area, is about the digital twins usage to support the AEC. We know that in construction, in civil engineering work, they would need the geodata. In this case, there's a lot of work to look at GeoBIM and looking at how this geodata can support the planning, the design, the building, as well as the progress monitoring of my team is working with different agencies on this. The application of digital twin for smart city, I think everybody knows this. There are many areas. I just want to pick up 2 here. One of them, important one, is for the future. TU with CAS has used our digital twin to work on this area. Last but not least, the development of autonomous mobility is a big area of research in Singapore, and our team has been working with the different partners to look at how the digital twin data can be used in all these areas. So what is next? I just put up very simply 2. We are looking into 3D property information. This is about indoor, this is about the address. And the other part is, of course, underground and indoor, the various techniques that we have and the various techniques to model them. But in this case, we need to look at a very sustainable way to be able to capture this data and continuously sustain and update all this information into our digital twin. Of course, all these are work to be done. It's coming up. We have not started some of this work, but the idea is all there. So digital underground is our another work here that we have started to look into with all kinds of technology. I'm going to my last slides. I know that I'm running out of time. So again, the idea here is the digital twin going underground. We are really looking at full above ground and underground digital twin for Singapore when we move forward. Yeah. I'm going to move to my last slides. So for next work that we are going to do is really again into the database management. This is a very important part of our work. So database management and ontologies to be developed for the digital twin. I'm going to to stop here. Apologize for taking too much time here. So I'll stop here. I'll pass the floor back to Asha.
Thank you, Dr. Victor. Thank you for the presentation. So for those for our audience who has any questions for Dr. Victor, do key in your questions in the Q&A box. So without further ado, I shall hand off the next presentation to Chun Hong from the Land Asset Management Division of SLA, who will be speaking about managing contractors through geospatial technologies. Chun Hong, please.
All right. Okay, good afternoon to all of us. My name is Chun Hong from SLA, and I guess for the past few days, we've all seen the power of geospatial technology, and I'm just going to continue to talk about how geospatial is like a mage in my work. So let's go. So in SLA, I'm from LAMD, and one of the core business that we do is actually to manage vacant state land and state buildings. So as you walk about on the street, sometimes you will see a signpost that says state land, then that means that we are taking care of them. And sometimes you might even catch us on the ground, no matter rain or shine. We are doing site inspection and hoping that all is good. So yeah, that's one of the core things that we do. And let me just share with you some numbers. For state land wise, we are taking care of 1,400 pieces of state land, and for state properties, 190, and we also manage 10 islands. And this is how the state land will look like. And it can be vast piece of green like turf land or even forested. State properties wise, we have quite a mix. We have former schools, hospitals, camps, and even fire stations. And these are 10 islands that we are taking care of, and perhaps one of the more popular ones will be St. John's. You might have been there before. So from all this, I guess you can see that our plates are quite full. So we think we have to engage contractors to help us do our work. And the contractors will mainly do these 4 things: grass cutting, housekeeping, vector control, and security. So in GIS, this is how it works. We assign works to contractors. Contractors will then perform, and then we'll evaluate their works. So how do we assign? We have this in-house app called the Contractor app. So Contractor app is a mobile app that enables our contractors to receive the assigned work, to document down the works done, and also to send service reports through the app to us all on the go. This is how Contractor app looks like. So I'll just zoom in. And when contractors log into Contractor app, this is the thing that this is the page that they will see. You'll see that the UI is very simple, and essentially there are just 2 parts. On the left is this task list. This task list includes all the sites that we have assigned to the contractor. And when they log in, they will see that there are 2 colors in the task list. One is the white task. Those white tasks means that they have not done any work. No service report is sent to us yet. And for the pink ones, it means that they have already done works and service report is already sent to us. So when they log in, they know for sure which are the sites that they need to focus on. And on the right is the map. This is where the geospatial power really comes in. The base map is one map, and then the map will also correspond to the task list, just like that. When they click onto the task, they know exactly where the site is, because we want the contractors to know exactly where the site is, so they will be doing works on the correct sites. So they can even check when was the last check-in date and time for that particular site. And so how do they use the app? Essentially, there are 3 things they need to do. First, after they check into the site, they have to take photos of the work done, and also they can enter comments. And thirdly, they just have to click save. A service report will then be sent to us through the app. So behind this very simple UI, there are more complex and yet customizable built-in controls. So these are the 4 of them, and I shall go through. So first is ensure proximity to site. This means that the contractor must be on site or at least very near the site in order to then check in and then to document down the works done, and then the service report will then be sent to us. And of course, if it is good, then payment will be made. So what happens, if the contractor, just like all of us here in the comfort of our seat, trying to think that, okay, grass cutting, grass, they look all the same, you know, so I'll just check in from the comfort of my seat, I'll just take a picture and say that, you know, the grass is cut. So what would happen? The app would then tell them and say, hey, you're not within the site location, please try again. So this the first gate to sending a service report. So without this, they cannot even send a service report, so no payment would be made. And this also ensures that they are doing works on the correct site. The second building control would be the required number of photos based on the size of the site. You know, we all say that a picture says 1,000 words, but perhaps not the whole story. So what we've done here is we have this building control that says that for those sites that are smaller than 5,000 square meters, take at least 2 photos. 5,000 to 10,000 square meters, at least 4. And any sites that is larger than 10,000 square meters, at least 6 photos. And this building control is good because at any point in time, you think that, you know, 2, 4, 6 photos are not enough. You can increase the number. Or when the contract specs has changed and you really do need to change the number, then you can change and you can straight away use it. So what happens if the contractor did not take the required number of photos? The app will then prompt them and please take how many more. And the third building control is site coverage tracking. This perhaps one of the one that we are most proud of. This because this actually came from a contractor who has been using our app for a while. You know, he told us that the app is good. It has helped them a lot. And because one of the things that we do is because we have to assign sites to the contractor, right? So one of the sites that we assign to contractor is quite huge. And then they told us that they wanted to know where they have worked. So they asked, can we see our own tracking path as we work so that we won't miss out any part of the site? And we think that this is very, very good. So we thought, yes. So here we are. We have this thing called site coverage tracking. So contractors can know where they are as they carry out their work. And the fourth building control is system generated date and time. So back to the first contractor that says, you know, I can check in from anywhere. So let's just say, you know, the contractor has missed out doing work on the particular site for a particular day. You know, he wanted to, okay, let's just change the device date and time and just, you know, just send it and deem it as I've done the work on the particular day and time. But what will happen is when the service report is sent to us, the service report will only reflect system generated date and time. This means that our service report is foolproof. We know exactly when the work was done. We know exactly how the contractor has carried out their works. And this is how the service report looks like, with the map on top, of course, with the tracking path, and also the photos taken by the contractors when they use the app. So I guess there are a lot of good things, you know, from contractor, and I really want to just narrow down to 3. So the first would be time saving. I think the time saving works for both contractors and us because in the past, before contractor app, what they have done is their workers go on site, take photos, and then when they go back to office, they try to piece out, okay, this photo is for this site, this photo is for that site. And what happens? It means that the service report that is sent to us is months late. So it's not meaningful for us to look at past reports, and it is also and it also consumes a lot of time on the contractor side. So when the contractor can use the contractor app and then will send a service report to us, it saves time for them too. And this also means that the payment to them will also be on time. And the second thing about this is really the quality of the service report. So from the report, we can see that how they have done their work, and we can see all the photos from the app. And also the third thing, right? We are, you know, we have assigned works to contractors, and they can instantly see which are the sites to focus on. So these are the 3 main good things about contractor app. Okay, so we have seen how we've assigned, how contractors perform. So how do we evaluate their works? So we evaluate their works using also another in-house app called SmartLAMD. So SmartLAMD is a mobile app that enables our field officers to access spatial layers, to document down the site inspections, to receive and then to respond to feedback, and also to view contractors' tracking path on the go. So this is how SmartLAMD looks like. when our officers log into SmartLAMD, this is the first thing that they will see. They'll see this KPI page. This KPI page is very important to them because at one glance, they know how much work was done, how much work was left undone, so they know which task to focus on. And you'll see that their task list is quite similar to contractor app, whereby on the left, it is the task list, all the sites that are assigned to us, and then also on the right is the map. So we can also view spatial layers on the go. We can see whose land belongs to who, and then also we have this transparency toggle, that because sometimes when we on the layers might block the road names, so we can toggle the transparency to able to look at the road names underneath. We can also do measurements on the go, like measure distance, measure area. This is important because, for example, if there's a fallen tree and we wanted to know perhaps how far is the fallen tree from the road, we can do a measurement. And yes, we can also receive feedback and also reply the feedback through the app. So our guys, they no longer need to go back to office just to see whether if there's any feedback. If there's any feedback, they can receive it in the app, and then they can also respond through the app. And job record, okay, this job record in our case is called site inspection tool. So when our guys, they want to rate the contractor's work, what we've done here is we've put in contract specs into SmartLAMD, so they know exactly what to look out for, and without having to remember so many clauses. So, oops, if there's no internet connection, I mean, what happened? Because we have some sites that are quite far flung, and the sites, sometimes there's even no signal on site. So what happens is SmartLAMD will then sense, okay, there's no signal now, let me go into this offline mode. This offline mode ensures that our guys can still continue to rate the contractors, and when the signal is up, they can the things, all the things that they have done will then sync back in. So we thought, we have these two very good apps, so let's combine them to give us even more power. So what do we mean by that? First, of course, when they use the contractor app and check into site, the next thing that will happen is SmartLAMD will tell you, hey, this contractor is on this site now. So we know for sure, okay, the contractor is doing work now. And of course, contractor then document down his work as per normal. And then SmartLAMD will then display the contractor's tracking path. All this will then translate into SmartLAMD is able to view service report on the go, and contractors can also receive the service report. And let me show you how it looks like on SmartLAMD. So this contractor has checked into this site on this day and time, and then there's a live icon. This means that the contractor is there now. Click on it and we'll be able to see the contractor's tracking path. And when the contractor has checked out, then it will tell us that, hey, you can view the service report on the go. And this is the service report. Of course, on top is the map and the tracking path. And below is the photos taken by the contractor. And I really want to sum Contractor app and SmartLAMD into this word ease, because I think these two apps together with geospatial powers, it really enables our officers and also contractors to work in a more productive way. And we are also very attuned to how we evaluate them, and they are also very attuned with how the assignment is being shared to the contractors. And together it makes us savvy. And we can also ensure that the service report is of good quality, and we can ensure that payment is made to them in a timely manner. So last but not least, I'll share one more thing. I hope that it will be quite good. So it is SUAVE. SUAVE stands for Smart Unmanned Aerial Vehicle Enhanced. So this is essentially a drone and machine learning technology that enhance our building inspections. There are 4 things that it can do. First, it will automatically detect what is the defect. Second, it can greatly improve safety, because now not only we have physical inspection, we have drones that can help us to look at state buildings. And we can also reduce repair costs and view 3D models. What do I mean by that? Let's go. Okay, so when our guys log into SUAVE, they can view the entire flight plan of the site. You see all these triangles on the map pointing towards a certain direction. This means that the drone is taking picture in a certain way. when the drone is flying. And on the right is what we call a defects list. This tells us all the defects that's being captured by the drone and machine. So this is a 3D model that I've just spoken. You know, this 3D model is very good because you see all the different pins, right, on the model. These pins are what we call the defect pins. This tells us exactly where the defect is, so we can make a very good sense. Okay, there's a crack here. Okay, there is a damaged roof here. So this is how the 3D model can help us. So let's just, you know, click onto it, and then we'll be able to see the picture taken by the drone. And this machine has automatically tell us that, hey, you know, this is a damaged roof, and indeed it is a damaged roof. And this can reduce our repair cost because we can early detect what is the issue before it becomes something bigger. So this is another example of how the defects, how the automated defects can show us, you know, like cracks and plants on buildings. Let me just zoom in. So you can see that the drone has automatically tell us that there's a crack and there's a plant on building. Now, why plants on building? Because the plant is so small. Okay, it's good that the drone can see such a small plant, but why? It is because we want to ensure that before the plant grows big and damage the roof, we may want to just, you know, remove the plants so that, you know, we can save costs in future. And, you know, so what if the drone did not detect some of the defects? So there are a few things that we can do. One, we can add defect into the picture, so we can train the accuracy, the smartness of the machine on the go. So if let's say there is a crack here, you know, and the drone did not pick up, what can we do? We can just click the add defect button. Once we click onto it, and then we can start to draw on the picture and tell the machine where the defect is. So once we have drawn, you know, we can just choose from a drop-down list that say, hey, this is a crack, hey, this is a damaged door, things like that. So this is how SUAVE works. So yes, I've come to the end of my presentation. So thank you for your time.
Thank you very much, Chun Hong, for sharing about what the Land Asset Management Division does over at SLA.